This lesson is on relations and particularly functions and what a function is. So by the end of this lesson, you should be able to explain the terms relation, function, domain, and range. Those might be new for you. Determine whether a relation is a function or not, and state the domain and range of a function given its equation, ordered pairs, or its graph. So we're going to start with a quick review about what a relation is. So we've been working with relations since elementary school. So relations are just a rule that associates one x value with another y value. We might not call it x and y, we might call it number of lawns and revenue, for example, but you have some independent variable that's related to a dependent variable with some sort of pattern. So here's an example of relation. We probably typically think of relations as equations, but they can just be in ordered pairs. We have the ordered pairs 0 and 0. When x is 0, y is 0, and 1, 10. When x is 1, y is 10, etc., etc. We can also represent this relation in a table of values, like so. In an equation, so this equation y equals 10x represents this table of values and the points in these ordered pairs. We can also represent it in a graph. So this is the graph of y equals 10x. Or this one might be new for you, but as a mapping. So these points here, they actually don't correspond to the other points we've been using here, so don't get confused. But this, in our first oval, we have what's in our independent variable. So these are our x values, and then these ones are our y values here. And so what this mapping means is when x is 0, y is 2. When x is 1, y is 3, etc., etc. So really we can translate these to coordinates, where the first coordinate is 0, 2, the second coordinate 1, 3, 2, 4, 3, 5, and etc. So in this example, the arrows are going straight across. They don't always have to be going straight across in a mapping. 0 might be mapped to the number 4, which means that when x is 0, y is 4. But in this case, you just sort of follow the arrows across. So now that we're comfortable with the word relation as just a pattern that connects an x value to a y value, we're going to look at two other words. One is domain and the other is range. So these are just fancy words for a very simple concept. The domain of a relation is the complete set of possible values for the independent variable. What this means is that the domain just represents all possible x values of a relation. So if we were to take a look back up to these relations up here, so we have here this pattern that we looked at, which is the number of lawns versus revenue. So we can imagine that this maybe is a student who's mowing lawns for the summer, and if they mow 0 lawns, they can make $0, 1 lawn, $10, 2 lawns, $20, etc. So the domain would be what is X allowed to be? Well, can a student mow -1 lawns, -2 lawns? No, that doesn't make sense, which means that the domain of this function would consist of 0, 1 lawn, 2 lawns, 3 lawns, 4 lawns, 5 lawns, etc., up into a certain maximum, since maybe theoretically they can't mow an infinite number of lawns. So now taking a look at the word range. So the range of a relation is the complete set of all possible values of the dependent variable. So all this means is what are all the possible y values of a relation? So let's take a look back at our lawn example. And so our y value or our dependent variable is revenue. So in this case, can revenue be negative given the situation we have where we know that we can't mow a negative amount of lawns, therefore revenue can't be negative either. Revenue can be $0, $10, $20, $30, $40 to a certain maximum, and that maximum would be dependent on our whatever we say is our maximum number of lawns. So that's the domain and range of this particular situation. Let's apply it to a few other examples. Let's take a look at example number 1. So example number 1 says state the domain and range of each relation. So let's go ahead and do our first relation right here. So it just says set of coordinate points. So this is in set notation. There's only 4 points in here, and therefore to our knowledge there are only 4 points in this relation, and that's allowed to happen. Not all relations have to be infinite. So taking a look at this example, we're going to learn how to write domain and range in set notation. So in mathematics, it has its own language, just like English and French, etc. And so instead of writing out the whole word domain, we're actually going to write out D and then a colon. And then we are going to copy this curly bracket that we see up there. And what we're now going to do is we're going to list out all the possible values. So here we don't have an infinite number of values. We have x can be 1, x can be 2, x can be 3, and x can be 4, and that's it. So there's no range. There's just 4 options. So we're just going to list those 4 options. So remember, D stands for domain, which is all possible x values. We're just going to list them. So the domain of this relation is going to be 1, 2, 3, and 4, and close bracket, because that is it. So now let's do the same thing for the range. Instead of writing range, we're going to write R, curly bracket, and we're going to again list out all the possible values, y values. So we have 5, 6, 7, 8, and it's as simple as that. So we're going to list out 5, 6, 7, 8, and we're done. Let's take a look at the next example. Now we don't have any points, we have this relation, but we recognize this relation. Y equals x squared, that's just a parabola. And it's the parabola that we worked with over and over again in grade 10. So we're just going to do a quick sketch to figure out what the domain and range would be. So we know that this parabola has to go through the origin. That's its vertex, and it's going to come down and come up, something like this. Again, here's our x-axis and here's our y-axis. So now we're going to ask ourselves, what are the possible x values and what are the possible y values? So take a look at this now. We got to figure out, what is x allowed to be in this parabola. So think about it. If I were to get you to write out every single one of these coordinates, so even the 1.1 and 1.11113, what is x allowed to be, and more importantly, what is x not allowed to be? So I like to start when x is equal to 0 and move down the number line this way, and then move down the axis the other way. Is x allowed to be 0 in this relation? And the answer is yes, because the point 0, 0 does exist. How about at 1? Is x allowed to be 1? Well, when x is 1, it hits the relation again at 1, because 1 squared is 1, so that's allowed to happen. How about when x is 2? Is that going to hit the relation? Yes. Switch to a lightsaber because it's easier to point. Here we go. So when x is 1, hits the relation, so x is allowed to be 1. How about when x is 2? Well, it's going to hit it at y equals 4, so that's allowed to happen. X is 3. Yep, it's going to hit the relation. X is 4. What's happening is I'm not hitting the relation anymore when I'm bringing up from x is 4. But I know that theoretically this parabola is going to continue on infinitely, which means that x is 4 is going to be on the relation, as well as x is 5, as well as x reaches infinity. So that means that for this relation, x can be 0 as well as anything positive. And how about on the negative side, we're going to see something similar. X can be -1. X is going to be -2, x can be -3, x can also be -4, because we know that this parabola is going to continue on and on forever. X can be -100, x can be -infinity, which means that x can be absolutely anything. So how we write that in math is, first of all, instead of writing the word domain, again, we are going to write the letter D, and then a colon, curly brackets. And then we're going to write x is an element of all real numbers. So each of these symbols have a different meaning. So the first symbol we know, the first symbol is x. We know what x means. This E stands for the word element. So you might also see the E written this way, and that's perfectly fine. So x is an element of all real numbers, and all real numbers are all the numbers that are on this number line. So that would include -5, it would also include +5, it would also include positive 5.000001, every single number up until infinity, as well as up until -infinity. So now let's take a look at the range. So the range we know, or what are all the possible y values that it can be. So again, I like to start at 0 and then work my way up the number line and then down the number line. So can x be 0? Let me take out my lightsaber again. Okay, so in this case here, sorry, can y be 0? Well, sure. At this point, y can be 0 because when x is 0, y is equal to 0. How about when y is 1? Does it hit the relation? It does, in 2 different ways. So there's 2 different points will give us a y is equal to 1. How about y is equal to 2? It's going to hit the relation again. Y is equal to 3. Keep on going. How about y is equal to 100? Well, we know that this parabola is going to continue on infinitely, both of these arms. So yeah, y can be 100, y can be positive 1,000,000, positive infinity. Now let's go below 0. So we know y is allowed to be 0. Can y be negative 1? Is there any value in this parabola where y is going to equal negative 1? The answer is no. We're not hitting the relation at all. How about when y is negative 2? We're going to hit this relation. And you're probably figuring out no. So that means that y can't be anything negative. So when we write that in the range, we write it a particular way. Instead of listing the things y can't be, we're going to list what y can be. So we're going to start off with r for range. So the range, colon, curly bracket. So the range is that y can be any tiny little number. So we're going to start off with y is an element of r. So y can be any tiny little number, but, and we're going to use this line to represent but. This line actually means such that. So right now we have y is an element of r such that, or but, y has to be greater than or equal to 0. So we're going to write this. Y has to be greater than or equal to 0. So if I were to read that out one more time, y is an element of r such that y is greater than or equal to 0. Another way to say that is y can be any tiny little number, but it has to be greater than or equal to 0. Let's move on and let's go a little bit faster. So the next relation that we have is this line. So we know it's a line. We've got to figure out what's the domain and what's the range. So a quick sketch. We know that this line, just using our knowledge from all the way from grade 9, we know that this is our slope. Our slope is negative, and this is our y-intercept. It's 3. So I'm just going to generally draw a line. Okay, so it looks like it could have a y-intercept of 3, and it has a negative slope. Now let's figure out the domain and range. Starting off with the domain, let's again start with, if x is 0, will it hit the relation? And the answer is yes. When x is 0, we know that y is going to equal 3. Take a look at when x is 1, also going to hit the relation. X is 2, x is 3. And we can continue all down the x-axis here, and we know that because this linear relation is going to continue down infinitely, that all of these positive x values are going to be in the relation. Let's take a look at the negative x values now. At negative 1, we're also going to hit the relation, negative 2, negative 3, and it's the exact same pattern. We know that this linear relation is going to keep on going up, which means that x can be absolutely anything, and so we're going to write that using set notation. So the domain is that x is an element of R. So that's the set of the domain. Let's do the same thing for the range now. The range, let's start on the y-axis and let's start when y is equal to 0. Is y equals 0 on the relation? The answer is yes. It's this point right over here. Y is equal to 1, also on there. Y is equal to 2, y is equal to 3, and we can continue on. And it's going to hit every single point on this positive y-axis, which means that y can be anything positive, including 0. And let's do the same thing for negative. So negative 1 hits the relation, negative 2, etc., etc. So there's no values of y that the relation can't take on, which means that we're going to say that the range is the set of all real numbers. So y is an element of R as well. And finally, let's take a look at our last example. Hopefully you recognize this relation. It's a circle. And if you remember the equation of circles, we have x squared plus y squared is equal to whatever the radius is squared, and that comes from the Pythagorean theorem, which we went through in grade 10. Which means that if this number here is 4, that means the radius must have been 2. So this relation could be written as x squared plus y squared is equal to 2 squared. So if we were to do a very quick graph, we know it's a circle, so it's going to look something like this. More circular though. And we know that the radius is 2, which means this number is 2, this number is 2, and this number must be negative 2. We've got negative 2 here. So now that we have our graph, we can quickly do our domain and range. So starting with the domain, starting with 0, can x be 0? Well, yes, it's going to hit it at the point 0, 2, as well as 0, negative 2. How about 1? Yes, it's going to also hit in 2 different places. That's allowed to happen for a relation. How about, can x be 2? Absolutely. When x is 2, y is 0. How about 3? Can x be 3? The answer is no, we don't hit the relation at all. So x on the positive x-axis can go as far as 2, and let's go to the negative. It can be -1, it can be -2. Past -2, we don't hit the relation anymore. So that means that there's an interval that the x values have to stay on. So x has to be between -2 and +2, and it can be absolutely any tiny little number in between. So we're going to write that in a particular way. So starting off with our set notation, so we have our domain and our curly brackets. We're going to start off with saying that x is an element of all real numbers, meaning that x can be any tiny little number, but... So x is an element of all real numbers, but, or such that, it has to stay between these two values. So to write an interval, you're going to start with the smallest value, which is -2, and end with the bigger value. So we're going to start with -2, leave a space, we're going to write our variable in between, and then end with our bigger number, so our endpoint. And then we are going to write little less than symbols in between. So what this means is that x, or -2 always has to be less than x, and 2 always has to be the upper bound. So x always has to be less than -2. So what this is saying is x has to be in between -2 and +2. But this isn't a perfect answer, because not only can x be in between -2 and +2, it can also be equal to -2 and equal to 2, which means that we have to add little lines underneath these less than signs to indicate that it can also be less than or equal to. And let's close this down. So in English, this says that the domain is the set of all real numbers such that x has to be in between -2 and +2 and can also be equal to. So -2 is less than or equal to x, is less than or equal to 2. Let's quickly do the range as well. So we know range, or what y can be. We know that y can be 0 because it's going to hit the relation here. Y can be 1, and we run into a similar problem. Y can be 2, but y can't be anything above 2. And the same with our negative y-axis. Y can be everything up to including -2 and nothing below. So we're going to write the range in the exact same way. Range is the set of all real numbers, but it has to stay in between -2 and +2. And it can also be equal to -2 and +2. So now that we know how to find the domain and range of relations, we're going to look at a very particular type of relation, which is called a function. So a function is a very special type of relation where there's a unique output for each input. So this means that each value of the independent variable, we know that's x, must correspond to only one value of the dependent variable. If that's still confusing, think about it with this rule. A relation is a function when every time we plug in an x, we get only one y. So we're going to come back to this a lot. Remember, a function is when a special type of relation for when we plug in an x, we get only one y. So you might be thinking that's all the relations that we worked with, but it's actually not. We've already dealt with things that aren't functions just in this lesson. So let's go through and analyze what are functions and what are not functions. Okay, so let's take a look at these first two examples. They're just coordinate points. This says it's a function and this says it's a not function. Let's figure out why. So sometimes it's easier to see when coordinates are part of a function or not a function by writing them in mapping notation. So that's the notation we saw on the first page there in those ovals. So we're going to do the ovals together. So I'm going to do a first oval. That's for the domain, and then we're going to do a second oval, that's for the range. And in the domain, first I'm going to put a D for domain and R for range. And in the domain, I'm going to write down all the possible values for x. So we know that those values are going to be 4, 5, 6, 7, and 8. And in the range, I'm going to write all the possible values for y, which are 12, 15, 18, 21, and 24. And it's important not to duplicate any of the numbers. So if 4 appeared twice in the domain, we'd only write it once. And now we're going to finish up the mapping notation by mapping 4 to 12, 5 to 15, 6 to 18, etc. So we know that when x is 4, y is 12. So we're going to draw an arrow this way. When x is 5, y is 15. X is 6, y is 18. 7 to 21, and 8 to 24. So go back to our rule, which is that we know a relation is a function when every time we plug in an x, we get only one y, so a unique value of y. So as I see, if I put in a 4, I only get one value of y. 5, same thing. 6, continues. Therefore, this is a function. Let's take a look at an example of a non-function. So again, I'm going to put this into mapping notation. I have my oval for my domain, my oval for my range. I'm going to write a D for domain and R for range. I'm going to list out all of the elements of my domain. So here I have 4. I'm not going to write 4 twice. I'm just going to write it once. So we've got 4, 5, and 6. And in my range, I've got 12, 15, 18, 21, and 24. And now let's finish up this mapping notation. So when I plug in x equal to 4, I get 12. So I'm going to do 4 to 12. And the next one I see, when I plug in a 4, I also get 15. So 4 to 15 this way. And then I have 5 to 18 and 5 to 21. And then I have 6 to 24. So if I were to just take a look at this 6 to 24, one x value gives me one y value. But when I take a look back at 4, when I plug in a 4, I get 2 different values of y. So there's not a unique value of y, but there's 2 of them. Therefore, this does not follow the rule. It's not a function because the relation is only a function when every time we plug in an x, we get only one y. Let's take a look at a graph now. Let's take a look here. When I plug in each value, x value, I should get only one y value. So when I plug in x is equal to -2, I only get y is equal to 0. That's what this coordinate is. When I plug in x equal to -1, I also only get y is equal to 1. And I can continue it here. When x equals 2, y is equal to 0, continues. But take a look at this relation here. When x is equal to 1, I only get one y value. Perfect. Also one y value here, but then we're going to plug in x is equal to 4. So as I bring this up here, I can see that when x is equal to 4, y is equal to 2 different things. It looks like y is equal to 14 and it's equal to 16. So because of this, it fails our function test, which means that this is not a function, which is why it's in this category here. Let's take a look at a last example where instead of having points on a graph, we actually have a completed continuous graph here. So if I were to take a look at every single x value starting all the way in our negative x axis, if I plug in x is equal to -10, it hits the relation one time. Therefore, that has one unique y value. I continue here. And here, I'm only hitting the relation one time for every single x value. Now let's take a look at this example here. When I plug in x is equal to 3, I get not one, but 2 different values for y. So I get that y is equal to 4 and y is equal to 6. The only time this doesn't happen is right at this corner here. When I plug in x is equal to 4, I only get y is equal to 5, which is great, but it fails our function test everywhere else, or it just has to fail at least one other place, and we know it's not a function. So because when I plug in these x values, I get more than one y value, it's not a function. So we have a rule to help us when we have the graph of a relation to be able to quickly tell if something's a function or not. And that's using the vertical line test. So actually what we were doing, let's take a look at this relation right over here. We were actually pulling from the x-axis up and seeing how many times it hit the relation. And if it only hits it once, we know it's a function. So what we're really doing is we're drawing vertical lines. And so if you draw a vertical line through a graph at any point and it hits it more than once, like here, it's automatically not a function, and that's called the vertical line test. So if I continue to draw vertical lines here and only hit the relation once, we're good. So let's quickly do these. So does this pass the vertical line test? Well, let's draw a vertical line. Obviously not, because when x is equal to 1, y is equal to 1, 2, 3, 4 different values. So we know that this is not a function. Okay, let's take a look at this parabola here. Is this going to pass the vertical line test? Well, it passes it there, but does it pass it everywhere else? And the answer to that is yes, it is a function. So we have a function here. Okay, let's take a look at this linear relation. Drawing a vertical line test, this linear relation is going to continue on forever, and it's never going to hit this vertical line more than once, so it is a function. And how about this ellipse or circle? Is this going to pass a vertical line test? Well, if I put it right on the side, it is, because it only hits the relation once. However, if I put it right down the middle, automatically fails the vertical line test because the value of 2 gives us two different y values. Therefore, this is not a function. So let's do a quick knowledge check to make sure that you understand everything in this lesson. So for each of these examples, we're going to determine whether or not they're a function, and we're going to also add something. We're going to write their domain and range. So let's take a look at this first guy here. Is this a function? Let's check. So let me start by, some of you might be able to see right away whether it's a function or not. Many of you will need to write in mapping notation. So I'm just going to write in mapping notation. So I've got an oval for my domain, an oval for my range, D and R. I'm going to list out the elements in my domain. So I'm going to put them in from least to greatest so I don't double up. So I've got -2, so I'm jumping right to here because this is our smallest value of x. So I'm going to do -2, -1, 1, 2, 3. Here we go. So I've got -2, -1, 1, 2, and 3. And then I'm going to put in order our elements of our range as well. So I have -1, 0, 1, 3, and -3. So our smallest is -3. And then we have -1, 0, 1, and 3. Hopefully I didn't miss any. We'll figure it out as we go. Okay, so now let's do our mapping. So we have 1 gets mapped to -1. So here we go. 1 gets mapped to -1. Next, 2 gets mapped to 0. 2 gets mapped to 0. Next, 3 gets mapped to 1. -1 gets mapped to 3. And -2 gets mapped to -3. So is this a function or not? Some students think, oh, this is crossing, not a function. But crossing has nothing to do with whether something's a function or not. Remember that every value of x should only have one value of y. So let's check that. -2, only one value. -1, one value. Each of these x values only have one value. So therefore, yes, this is a function. This is a function. Okay, so let's add a little bit more difficulty and write out the domain and range. Since we have a finite number of points, instead of writing that x is an element of R, which means x can be any real number, that's not true. X can only be these finite numbers, 1, 2, 3, -1, -2. So we're just going to list that. So we're going to say D, our domain, is a set of numbers, -2, -1, 1, 2, and 3. And we're going to do the same thing for the range. It's not an element of all real numbers. It's just a set of finite numbers. And those numbers are -3, -1, 0, 1, and 3. Let's move on to the next example and quickly set up our domain and range. So we have our sets of our numbers in our domain, sets of numbers in our range. I'm going to write them in numerical order. So we have 3, 2, 4, 3, and 1. So we have 1 is our smallest. Then we have 2, 3, and 4. And in our range, we have 3, -1, 1, -2, and +2. So we've got -2, -1, 1, 2, and 3. And let's quickly map these. So 3 is mapped to +3. 2 is mapped to -1, 4 is mapped to +1, 3 is mapped to -2, and 1 is mapped to 2. Okay, is this a function? Hopefully you're saying no, because 1 is mapped to just one y value. Excellent. 2 is also mapped just to one y value. The problem is at 3. Right here is the problemo, and that is because 3 corresponds to a y of -2 and 3 corresponds to a y of +3. Therefore, it is not a function. Not a function. So now let's quickly do our domain and range. Try the domain and range on your own. Pause the video now and just check to make sure you've got the right answer. So here is our domain and range of the function. Make sure you've got the same thing. Let's try this next example. So here now we have just an equation. And if you can tell, this equation is a circle. So if you can visualize this, we know this is definitely not going to be a function. Because if I were to draw a quick graph of this, we know it's a circle, and the radius, we remember the equation of a circle, we did it previously, is x squared plus y squared is equal to r squared, which means that this 9 was 3 squared. So therefore we know that our radius is 3, which means that this must be 3. It's not perfect. This is -3, this is +3, and this is -3. So is this a function? Well, every x value must be mapped to only one y value. However, it does not pass the vertical line test. If I were to draw a vertical line, it hits the relation 2 times, which is more than once, which means it is not a function, does not pass the vertical line test. So it is not a function, not a function. If you can do this without drawing, that's completely fine. Let's quickly do our domain and range. So we have our domain, and I would pause the video here, try the domain and range on your own, and make sure you get the same answer as me. Okay, so you should be checking your answers right now. Things to pay attention to. Make sure that you have less than signs and not greater than signs. This is not going to give you the right answer. Make sure we've got less than signs. The other thing to look out for is make sure that you have equal to signs in here, since x can both equal 3 and -3, and y can both equal 3 and -3. Taking a look at this example, we know that this is just the equation of our line. We have our slope, our m is -1/2, and our b, which is our y-intercept, is 5. So super quick sketch. We have the line should look something like this. Okay. So very quickly, let's try this vertical line test and see if this is in fact a function. Whoops, there we go. Okay, so passes, 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 passes. Yes, this is a function. And if you were to play around with it, is there any line that you could draw that wouldn't be a function? So keep drawing different lines. Like, would this be a function? Yes. How about this horizontal line? Would this be a function? Well, if we were to do the vertical line test, it would only hit it once. Once you play around with it enough, you're going to realize that the only line that's not a function is a line that's completely vertical. Because we know that if I were to draw a vertical line exactly through that line, it's going to hit it an infinite number of times. So as long as your linear equation is not the equation of a completely vertical line, a linear relation is always going to be a function. So we know that yes, this is a function. And now let's quickly do our domain and range. Pause the video here and play it again when you think you've got your answer. Okay, check your answer here. We know that there's no restrictions on x and no restrictions on y, so both the domain and range are the same. X and y are both elements of all real numbers. So we saved the easiest to last, because if we take a look at a graph, it's very simple. It's very easy to check whether it's a function or not, because we can always use that vertical line test. So this is a parabola. We know that it's opening down. As I draw my vertical lines, I can only hit this relation one time. Therefore, it passes the vertical line test, and yes, this is a function. Let's quickly do our domain and range. Again, pause and play when you think you've got it. Okay, check your answers here with the domain and range. For the domain, there's no restrictions on x. This is going to continue infinitely. For the range, we know that y, because this parabola is reflected in the x-axis, y, the greatest value of y can be 1, so y has to be less than or equal to 1. So make sure that this is a less than sign and not a greater than sign. And our last example here, we seem to have a parabola that was flipped on its side for some reason. So if we try the vertical line test, it does not pass. It passes here right along the y-axis, only hits the relation once, but at every other place it's going to hit the relation more than once, therefore it's not a function. Not a function. And let's quickly write out the domain and range. So pause the video, try it yourself. So here's the correct domain and range. Here we have a restricted domain and a non-restricted range. So y can be anything, because if I pull from this y-axis here, y can be anything positive and y can be anything negative. But if I take a look at the x-axis now, we know x can be 0, x can be 1, 2, 3, but it can't be -1, -2, which means that x has to be greater than or equal to 0 and y can be anything.